This is a continuation of our Chapter 8 handout. This is 8.3, and we're going to do some more confidence intervals. This is going to be for the proportion of a sample and the proportion of a population. We've been doing them for the mean of a sample to estimate the mean of a population. Well, a proportion is just how many things you're interested in out of the total, okay? Now, it says, recall from Chapter 7, we did not do this particular lesson because they use population proportion, they use pi. And we were already using pi for our binomial formula, so I didn't want you to get confused. So our population proportion, they're going to use the symbol pi, and that's typical in math for them to use something more than once. My point estimate is going to be little p, which is just the number of things out of the total. We'll see this in an example. And we will be using z, so make sure you have your little cheat sheet handy with your z values. We don't have to look at our z chart because we know them for the 95%, 99%, etc. And so here's what our estimate looks like. And let's just go ahead and do one. Okay, a random sample of 100 people shows that 25 are left-handed. So our little p for our sample, 25 out of 100, a proportion is just a fraction or a decimal. And we're doing a 95% confidence interval to find out the true proportion of left-handers. How many left-handers are there in the entire population? So our estimate, and again they're using pi, is little p plus or minus. Now z for 95%, we should have that written down on a little cheat sheet somewhere because we're going to use that a lot. It's 1.96. The formula, you take the square root, you take little p times 1 minus p, 0.25, times 1 minus 0.25, and that's over n. We had 100 people in the sample, so that's 0.25 plus or minus 1.96. I put this in my calculator and did the operations underneath, took the square root, and I got this decimal. And I just rounded it to 4 places. And then let's do another in-between number. So 0.25 plus or minus, let's go ahead and multiply that. I get 0.0849. And again, just like I've done before, I'll add to get the upper number and subtract to get the lower value. So my estimate for left-handed people, if I add those two together, I got 0.3349, about 33%. And if my lower number, I got 165.1, about 17%. So based on that one sample, I'm 95% confident, not 100% confident, that the percent of the population that's left-handed is between 17 and 33%. Well, I was just kind of curious, and I'm Googled it. It's actually 10%. So remember, this is a confidence interval. It's never 100%. Okay, this next one, we have a cell phone provider trying to see if they offer a new cell phone with improved features at a reduced cost, how many people would want it. They took a random sample of 500, and of the 500, 135 people indicated they would upgrade. So little p, my sample proportion is 135 out of 500, which comes out to 0.27. And pi, my population proportion in this case, is 0.27, little p, plus or minus. Now let's see, we have 99%, and we know that that's 2.58. We wrote those numbers down in lesson 8.1. We're going to do our square root. I've got 0.27 times 1 minus 0.27 over the number of people in my sample, which was 500. That's 0.27 plus or minus, I've got 2.58 again, And I'll show you what I got on my calculator for this. And I'm going to multiply those together. If you catch any errors in any of these videos, let me know. And we're going to add to get the upper number and subtract to get the lower number. So I'm assuming for my entire population of my subscribers that about 32% and about what, 22% if you round that. So between 22 and 32% would want to buy into that new feature there.